morning, Tyler.
This is like good morning. This is like the most official thing we've done
Yes.
yet with these Delta Lake Live things.
It feels very committed. Absolutely.
So I should tell you where I am because my audio is crap, my video is crap. Like I feel like I'm in a fishbowl a little bit. So I'm in San Francisco. We have an office in San Francisco, and I have stuff to do down here today. So I had to leave my humble garoffice, where I'm usually coming from. So I can't really fix the audio because it's coming through my Bluetooth headphones. And I also don't have a good screen share setup. So you get to try it for a change, which is a nice break.
Yeah.
I'm just gonna sit back and relax and say, you should do this. You should do that.
Excellent. Yeah, I'm a little bit concerned because if people watch this and have been following, they might be falling asleep today because I'm nowhere near as kind of fast and need to rely on IDEs and things like that.
You need to rely on IDEs. So
sorry about that.
That's okay. I have caffeine, so I won't fall asleep. I can assure you that. I hope you have something to drink. I just wanted to let you know from last week. I've got this. I mean, this PR. It keeps snowballing, just ripping bad strings out left and right to make URLs sort of what we pass around everywhere inside of Delta RS. I pushed some updated changes to that pull request this morning, which you don't need to go review. There's even more things, but I'm like slowly getting higher and higher in the stack where I'm now working on integration crates. Our log store trait has to be changed. And then there's the Python level, which I started a thread to chat with Florian and Ian about, where we're actually returning strings directly, like raw strings directly to the Python layer in a lot of cases. And then the Python layer takes those and gives those back to us. And they're not like, we have to change to a more strong, like a stronger type, basically. Like we can't just be passing strings around and hoping that they're properly formed URLs. So I'm hoping that later today, when I'm on the bus, I'll be able to finish this up, but we won't get to talk about that. So I'm glad that you have a topic to bring up.
I mean, this is a great avenue because I think in terms of moving to, well, not necessarily moving to kernel support, in our journey to have proper Delta support, and with proper Delta support, I mean, at its heart, the Delta protocol always said it's URLs and you can have anything in there. We were just lucky enough that almost all tables kind of default to a single location. So yeah, there's just enough kind of relative paths out there. But I think this is one very important step that we need to take in order to actually support it the way it's kind of meant to be. And then some other thing is what we're looking into right now, which is kernelizing the scan. And kernelizing the scan.
You mean what's on your screen right now?
That's what's on the screen right now. And maybe to give a little bit of context.
Yeah, so I mean, you've used the term kernelize a lot. Like one of our older big giant issues in GitHub is the kernelize. I think it's kernelize exclamation point. Kernelize issue. So we've been using Delta Kernel for a long time. We've had some types that we pulled in from kernel originally, and now we have log replay with powered by kernel. What is like kernelize exclamation point? What is that like? What's the end state to you in terms of what behavior sits in kernel versus what behavior sits in Delta RS and DataFusion? I see you have DataFusion on the screen. Like, when are we done? Like, when do we do one of these and say we did it?
So in terms of kernelize, but I mean there is this aspect we just talked about, essentially, that on the read path, we always process full qualified URLs. We have this kind of routing logic that selects from multiple object stores that need to be registered on some sort of session, yada, yada, yada. And all of this machinery, we have a version of this in Delta RS, and there is a version of this in DataFusion. Those need to fuse together, but all of this needs to happen on the Delta RS side. So when we say we do a kernelized scan, and this is kind of, at least architecturally, the end state for now, that we're working on for the read for the scan path. End state doesn't necessarily mean all the features are in there. End state means we're architecturally where we want to be. So you correctly said we already do the log replay using kernel. However, Delta RS traditionally has done something which is kind of like a two-phase approach. First, materialize the entire log, kind of materialize and reconcile the entire log, which was kind of just the log replay logic, right? And then the table kind of carried this state around all the time. So as we move to kernel log replay, we actually expose more and more of this stuff on a stream. Even though we have it fully materialized, we sometimes then just say, okay, we take this internal vector of record batches that we materialize, that we track, and then downstream all the planning, all the operations, they consume this as a stream, right? So, and this sets us up for never actually doing this completely eager work, but being completely lazy about it, right? But right now, we still have this kind of two-phase approach where we first materialize and then we consume it in the operations. So the log replay was just a materialization step. And what that gave us was support for, I don't know, log compaction files, V2 checkpoints, kind of all this fanciness that this log can have, that is sometimes optional, like the checksum files, for instance, right? They're completely optional optimization. But having kernel integrated for log replay allows us, or takes advantage of this, and gives us kind of, I don't know, for people who may not know the Delta protocol, like a checksum file, for instance, is something that can speed up what we call the PNM query, the protocol and metadata query, because it writes like a snapshot light kind of in there. But this is again optional.
I think you said checksum. Did you mean checkpoint?
No, checksum. Checkpoint is the actual checkpoint. Okay, so and
what's the check? Maybe I missed the. Are you like checksum means a lot of things?
Yeah,
talking about
checksum,
like
as in the
CRC
Delta
32, or the CRC stuff that gets written.
Yeah, let me actually we have something open here. I just need to find the test crate. Let's look at the data. What's kind of a fancy table? Maybe this one. Yeah, this is a checksum file.
Okay,
right.
The CRC file is what you meant. Yeah.
Yeah, but this contains kind of it contains it's a checkpoint light, right? We can get metadata from this and other content. And this is kind of optimizations that you can do during log replay that Delta RS did not support. And then there is the V2 checkpoints. There is log compaction files, which kind of combine kind of like a checkpoint, but just for a commit range. All of these kind of features we got by kernelizing the log replay. However, after this, we still just parse this data or process the data the way we did before, and do our operation planning based on this. And in this stage, this is where we need to read data from the actual data files. So this is where we need to apply column mapping. This is where we need to apply deletion vectors. and all of this kind of stuff. And this is what we're trying to achieve right now. We're trying to now also take the scan phase, and within that scan phase, kind of apply all of these things in order to support, well, column mapping and deletion vectors essentially are the most critical features in this regard. And they're also the most critical because a lot of tables have them by now, and we really need to support them.
A lot of tables do have them. Now, column mapping I see far less frequently. Deletion vectors is the big one that cause people problems. When I think about those two features, it seems like column mapping is the easier conceptually to support. Deletion vectors seems more fraught in terms of like the risk of screwing something up is much higher. Is that your feeling too, or does it matter, or like?
No, you're absolutely right. So there is a bunch of other features. Actually, right now, we could be really aggressive with deletion vectors. And with really aggressive, I mean really try to squeeze every ounce of optimization out of it by pushing the deletion vector right into the Parquet read. The Rust Parquet crates.
Or in?
No, that would be us setting up DataFusion and the Parquet abstractions in a way that the deletion vector gets pushed right into the read. However, there are things out there like row IDs and stuff like that.
All these other fun features.
Where this might really hurt us. So the way we will go about this now for the first iteration, actually, I think we don't necessarily need to land deletion vectors directly, but it could also be a very fast follow-up. But the first iteration of deletion vectors just says, okay, we'll read everything from Parquet and then apply the deletion vector after the fact. I think then we'll do row IDs, and once we have some testing infrastructure for row IDs, then we can start to experiment with other things.
So I actually don't understand, what do people use row IDs for? Like, I've seen that feature a couple of times, but I've never used it. Like, I don't know why people.
So I think if you have row IDs, it's much easier to generate like a change data stream and things like this. So this is one application I know where row IDs are important.
Is it just adding a primary key to the table that you don't have to worry about? Like a lot of the data sets that I work with already have, a primary key of some form that you could use for that change data capture use case. But
I guess it's doing this stuff, but baking it into the protocol somehow. I would say there's probably more around this or other applications of this as well. But yeah, I don't think it's a feature that deletion vectors and column mapping are the ones we should really do, and then we shouldn't set ourselves up once these other features come in, right? So we just be aware that there is some, how do you say? It's not there be pirates, there be dragons.
There be dragons.
Yep. Yes. So yeah. All
right, what are you showing me today?
How do we go about doing this? So we actually have something on main already, and I'm hoping to land more on main soon. But the main abstraction that we're looking into is the table provider. So right now, every scan that we do flows through DataFusion. We don't have a arrow Parquet only read. I think this is something we can provide, but since already everything kind of uses DataFusion right now, I think it's good to start with DataFusion and transfer that scan. And there, the way to go about this is to implement a table provider. So as you can see here, we implement a table provider for both of our snapshot abstractions. Actually, I think we should drop the table provider implementation for the core kind of delta table. Why? Because that thing may not be initialized, and the table provider always needs to know its own schema. So there is one thing that we can look at here, table provider for delta table. These lines here are what should not be happening. Yeah, that we've seen what an unwrap can do to the global internet. So yeah.
Delta RS is as load bearing as Cloudflare. You are correct. Yes, it is that important of a project.
At least. But this kind of tells us, because the delta table may not be materialized and there may still a lot of stuff be happening, it's not suitable as a basis to do actual planning. We don't want to kind of let DataFusion, I don't know, juggle with burning chainsaws and hope that it can get all the information at once. So that's why.
So I understand that. So when I think about how a lot of people are using things from DataFusion, like we're basically giving a table, right? A delta table. And one of the problems that we've had with that is then you've got this thing loaded into your session context, and if you do a dot load on that table, then there's like a concern that you might be working with out of date data in the DataFusion layer. Like moving a table or putting a table provider on snapshot, I don't understand why we need it on both snapshots, but I'll be confused about that for the time being. But what is, like, how does a user then start querying Delta information from DataFusion if the table provider on Delta table goes away? Do you know what I mean? Like, what's the ergonomics of?
Yes, we can see some of this, for instance, in this test that we are right now looking at. So the table does provide a new method which gives you a table provider builder, which can directly be awaited. So actually here, I think the into future thing is the right choice. I don't know
if love that into future.
Yes. But yeah, this is how you get a table provider right now. I think what we need to do is actually move away from the table provider and create them in the catalog abstractions, because this is where you can get sort of the fresh snapshot all the time. This will refresh it, but one thing we cannot do, in my opinion, is have the table provider dynamically update itself, because that may actually change the schema, right?
But in this case, I'm thinking from the developer's standpoint who's using this. This doesn't make it clear to me that, like, is this using just the latest snapshot? It's using the version, I assume, that's been loaded into the table. Is it, like, I guess, is there a reason not to just do like table.snapshot, like do register table and do table.snapshot and just let that, to make it clear to the end user that they're getting, like, the snapshot is what you're actually querying on, as opposed to a mutable Delta table instance?
Well, I did think about this a little bit, and I guess it's up for discussion. So why did I go this way? Because this is type erased. So type erased in the sense of this method doesn't resolve into like a snapshot, but the builder yields an arc table provider, so that we can make a choice what the actual implementation of that table provider is. So why is that important? Because right now we not only have the Delta table as a table provider, but we also have a separate table provider, which is why I introduced this builder, which essentially allows you to say, oh, but I want like the file column back. I want a column that says what file this data originated from, which is something that we require like in the merge implementation and stuff like this. And the raw snapshot cannot give us this, right? And because we have these kind of different variants of things, this is why, this is why kind of the table provider, needs to, we need to type, oh, this is why I wanted to type erase it, because having like 3 versions of table providers around there, and you shouldn't care. It should just be like a table provider that does what you needed to do. And then if you're an advanced user, you can customize the table provider, And you'll see that here, the file column actually isn't supported yet, right? So we don't do anything with this yet, but we know we need to. So right now, I'm just trying to get the scan right, so that it does what it needs to do. And then as we integrate it, we also need to support these kind of features. But yeah, that's the reason.
Okay.
But I mean,
the reason, like, this is not important for our discussion right now, but I think, you know, as we go to 1.0, you know, the long road, 5 years and counting to 1.0, I'm taking a much more critical look at some of our APIs and what they can, like, how they communicate to an end user on expectations. And with our DeltaFusion, or the Delta DataFusion integration, or that module, there's a lot of cases where we don't make it clear to the user what their expectations of, you know, what they can query, what they can write, what they can't write, what operations are available when they go into DataFusion, because we are sort of handing off responsibility a little bit when we go into, you know, we say, take this Delta thing and wrap it in DataFusion, which is an answer to one of the questions from the chat about, and I think it's a trolley question, but I'll answer it anyways. How do I export this to Excel? With DataFusion, one of the beautiful things about DataFusion is you have a session context, you register, you can take a, you know, take a Delta table, and then you can write to CSV. Like, as soon as you get into a data frame, you can dump it to any format, basically, that DataFusion supports. But that sort of like going up into the DataFusion layer, like, if we don't make the capabilities clear to the end user what they're losing or gaining when they do that, then we just get issues, like where somebody sees like, oh, I can't write this now, or this doesn't support deletion vectors, or this doesn't support blah 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 blah. You know, how do I reload my session context correctly with these sort of things? And I think some of those questions we can answer with clearer APIs that like sort of like make it absolutely clear what they're doing. So one of the changes in the pull request that I'm working on as an example is when Florian went through and did the initial pass of like converting strings, you know, string references to URL, he left a lot of APIs intact as like ensure table URI. So URI, or try from URI, but that went from taking a string to taking a URL. And so a convention that I'm introducing with the commit that I pushed this morning is anywhere we say URI, we're taking a string reference and it's going to become a URL, period. There's no discussion. But anything that takes a URL, the function signature has to say URL. Like try from URL means you have to give me a URL to make those expectations clearer without the type suggestions that you might get from an IDE. And I think there's a couple of other cases where we can probably get better about saying like, the into feature is an example where in this case, I think you're right, this does make sense here, but there are other cases where we do an into feature and we're losing the opportunity, I think, to communicate to the user that a read operation is going to occur here, or some form of behavior change is going to occur behind that .await on the operation. And so I'm just like, when I'm looking at how our APIs are being used or misused, as I try to do some of the URL work. I'm seeing a lot of cases where we just haven't communicated clearly. And so in the future with the DataFusion stuff, if we can, like 2 snapshots, I forget every week. I'm going to ask you every week from now until forever, because I can't remember the difference between snapshot and eager snapshot. I think that's API confusion. I think that's API confusion that we can get better about as we move forward. I'm not saying right now, but like as we move forward, making it clear when something should be used and when it should not be used.
I completely agree with that. I think the good news here is that this
scan tape, actually, that's a great method.
I mean, what I'm showing you here is, and I think we talked about I know we talked about this on a discussion. This actually has nothing to do with kind of the work right now. It's just what would it look like? And you see, this isn't staged, and it's not going to be part of this PR. But what would it look like if we exposed our ops on the
I like that,
on the Delta table, and then have more of this kind of a data frame-like experience? And we need to know, or we need to see what this looks like, and we also need to normalize on what these methods return, kind of init streams. How do you access metrics? How do we get you like the refresh new state of the data frame, right? Because here traditionally we wouldn't want to mutate the data frame, but just give you back a fresh one that's now your next one. So we should definitely look into all of this. The good news here is the change we saw here, like this table provider method, we don't need to include this. So my thinking was, let's merge this still in next, still hidden away. Right, I'm just going through I'm just going through all the tests now, and I'll leave the changes local to the actual tests, but have kind of the integration into the crate where we make the switch from one table provider to another, have that be a separate step. And I think that PR is exactly where we need to have the discussion around what should APIs be looking like. There is a little more to this even. So you see here, we already have our custom session. We have a Delta session context that existed before, but this wasn't consistently used, or isn't consistently used. So sometimes we created a new session, sometimes we got another session, and a lot of people want to give us their DataFusion session, which is something they should absolutely be able to do, because they should be able to include stuff in there. However, now it gets even more interesting because there are some things that we may want to kind of handle on the session and update in the session in order to make things work properly. So there's some interesting API discussions coming up. And also, how do we kind of bring our config system into the DataFusion config system? Because I think the expectation from, let's say, somebody who uses a SQL front end with something in the back end that is DataFusion is that they can also set properties kind of in there. But the good news is we can kind of, I think we can harmonize, kind of use our configs when we do, but still feed it through that we can read it from the DataFusion session once that becomes available, or if we're in a context where that's available. But I'm just saying there's some larger discussions for us. Right now, I'm just hoping to get the scans working to do to do column mapping.
So one of the things with the column mapping that you've made assertions about that I'm curious of is, if we solve this with the DataFusion at the DataFusion layer, then that's where we're doing reads of data, basically. Does that hold true when you're coming through from Python and pulling things out to PyArrow, or I guess it's Arrow 3 now, but Arrow 3 record batches and things like that? Does that still travel through that same DataFusion code path?
Actually, I did have a discussion with this somewhere with Eon.
Mm-hmm.
So sometimes, but in one of the previous PRs,
Sometimes. Okay.
So obviously that's not a good thing. And let me see if I can kind of find this really quick. I think it's in here, maybe in table. Now not create partitions, files. So I guess what I'm saying
is like, is there refactoring that has to happen in the Python layer to narrow the possible code paths going into the Rest layer for doing the table scans?
So one thing that we added, and I can't find it right now, but somewhere in here is to Pyro dataset. That's kind of the problem. We can't create these datasets anymore, or these datasets cannot support all of the features, because this is now the lazy abstractions from Pyro that don't know anything about column mapping, about deletion vectors, about all of this goodness, right? So here we're just handing off the files. We're adding some metadata so that that Pyro can do its optimizations. But
so we're giving Pyro the files. We're not giving the Pyro record batches here.
Exactly, but we introduced this here already, so this will blow up. We probably should add the alternative here, which API should be used, rather than saying it's not data sets. But the answer is, if you use to Pyro table, well, this also goes through the bait data sets. But ultimately this mustn't go through the data sets then, right? Here we have
the data set support has to go away for more advanced tables, but there are other routes that we would be able to support, like going to a table or just a stream, like a stream of record batches. Okay.
I mean, I think the API that I actually favor is this one that we have in the query stuff, because this just returns. Okay, and Tyler just disappeared. Well, maybe it's coming back. There we are.
You know, sometimes you just wireless networking. What are you going to do? I was about to say, maybe the network was proactively kicking me off before I said something stupid. I added this code like a couple of years ago. I actually use this a lot. Whenever I'm using Python, I'm using this stupid query builder. Like, it's the simplest, dumbest API. But I actually, like, I don't understand pandas. I don't get polars. Like, I don't understand this. Like, I just want just give me some SQL queries to give me some record batches and I'll figure it out.
But I mean, I think this is exactly the abstraction that we should expose also everywhere else, because this is something that DuckDB, Polars, Pandas, all of them can read this thing. And if they want to use the Pyro abstraction, I mean, at some point we also have to be confident enough that we did enough optimizations on the read that we can kind of match what a Pyro dataset can do, in terms of how quickly do you get your data to your machine, sort of. But yeah, so this is where we're at right now. Let's maybe.
So how do you want to order this? Because your work here is going to conflict heavily with the stuff that I have in flight. Like, I think I've touched 100, 200 files at this point.
So,
with this pull request.
well, what I want to do is keep this PR contained to the
Just for
table
that
provider next, and there will be like some other light touches around there, but don't integrate yet. So all the test updates, yada yada yada, all of this isn't there because that would be kind of an absolute nightmare to try to merge this alongside trying to merge yours. We need to rewrite this anyway. Right now, I'm just seeing that the tests are passing so that we have something good in the next folder that we can actually use for stuff.
So Eon mentions in the chat, I'm assuming that's him, that we also have a table provider PyCapsule thingy as well, so that DataFusion Python can register a table. So there's a couple of code paths, I guess. The PyCapsule stuff, I really don't understand. It's like magic to me, and I'm comfortable with that.
I mean, we do have Eon, so he'll unmagicify the magic. But
so your plan is that Eon's going to handle it. That's what I mean.
Nah, I think the most important stuff we already did, which is kind of the migration to Arrow 3. And we do need to discuss whether we want to retain some APIs like the to data set, which are only useful if certain features aren't enabled. But if users want them, I mean, might as well. And then if we can also integrate well with the various kind of table provider thingies, from Python back and forth into the DataFusion ecosystem, that's obviously also awesome.
I think the interesting thing about the PyCapsule approach is, I think, again, going off of memory, because I'm not going to bother looking at the code right now or trying to find it. Like there's the Delta table Python API. Underneath that, there's this raw Delta table sort of struct that wraps our Delta table struct. And I don't know if we expose a snapshot far enough up in that interface to make it easy for us to pull in or to use the table provider that you're working on right now. And so we might have to clean up some of those layers of abstraction sitting on the Python side that are a little brittle and difficult to test, in order to bring the table provider on snapshots that you're working on up to the PyCapsule layer.
I don't know either, but I'm confident we'll figure that out. But yeah, it's this is also a challenge because we have so many table provider implementations out there right now.
Yes.
Too many, I believe, definitely. Yeah. So, looking at our...
Have you done any performance testing? Does this change anything? Well, are you waiting for me to do performance testing? Because that's been your strategy in the past.
That continues to be my my strategy. I want to set up some more infrastructure that we can do. They also planned on maybe running the merge benchmarks.
Or that Abi had created.
Yeah.
Yeah, I think that'd be good.
To not kind of offload all of it to you, or at least not give you something that's obviously obviously wrong, or a regression.
The easy wrong things I think we should catch early before I have to create a custom build and deploy that into production and see what goes wrong.
Talk about keeping sort of the loops tight, right? If we can do that. Maybe looking into what we're doing now. So there is a bunch of tests already passing, which is some great news. Obviously, kind of this stops working once we go into some of the more advanced stuff. And our current table provider implementation does a lot of things, just a lot of things.
Yes.
Some of it maybe should be doing or shouldn't be doing, but I try to not just do all of it at once, but build it up piece by piece and see what's kind of the pieces we actually need.
That's on growth, Robert. A year ago,
Yes.
you would have showed up with 2,000 lines of stuff and say.
Well, it may still get to be a lot, but yeah, let's let's see where we end up. Kind of maybe the most important thing.
Hold on. Go back down to inside of scan. One of the things I'm curious about, I've done some optimizations elsewhere to try to avoid the use of clones. Like in Arrow, yes, your refrain has been correct in a lot of cases where Arrow as a zero cost abstraction gives you clonable things in a lot of cases. But we use clone as a crutch in a lot of places because we have a whole lot of things that we're sending across, tasks in the runtime. I'm curious if the direction that you're going and with the Kernelize, if we'll get to a space where we're passing a lot more by reference as opposed to cloning things left, right, and center, and potentially reallocating even references. I mean, a reference is not zero cost at a billion references being generated just to do a table scan, right? So like the direction that you're going in, does it move us in any way forward on reducing the amount of clones and increasing the references that we're passing around, or not touching it right now?
Well, let me put it this way. I hope so. I mean, here, this engine clone is something where we need to do it, but it's an arc. So try to do sort of at least the reference counted once whenever we can. There's one thing that kind of is already on main, but where
hold on, no. That wasn't go back. That wasn't what I was strictly referring to. 2 lines down, we also convert an iterator to a vector and then back into an iterator to pass it into the scan metadata from. Like the 2 vecs are a lot of places where I see us having something that is lazily loaded in some way, and then to pass it around because we don't have the best hygiene on lifetimes and references and things like that, because there's a lot of send and sync, right? We also turn things into vectors in a lot of places and make those allocations and pass those around. And so it's both, like, I'm not strictly speaking about this code, but like clone and 2vec are 2 of the places where I see lots of allocations coming. And I want to be in that lazily loaded or reference counted world, but we just have a lot of places where we're doing.
So this here actually, so let me, or am I doing this here? No, one change I believe we need to make. Let me see, now we're in DataFusion, let's go to the snapshot. One thing that you may or may not be referring to is this is we need the eager snapshot.
See, even you can't keep the snapshot straight. I don't feel bad about being confused.
All good. I mean, this is also a little bit of a crutch. It's deliberately a method that's kind of only within the crate, so that we can kind of error if the files aren't initialized. Because these could also be an empty vector, but I didn't want to have an option there because then we have to deal with that option. Here we just say, okay, if you access the files on the eager snapshot, but actually have this config that I want to get rid of eventually set to not load files, well, then we error out. But it's maybe more interesting to see where do we, okay, we still have this log data handler, but this, for instance, Here we do a self.
Now it's Robert's turn to get kicked.
Okay, but now I'm back in. I just cycled.
So eager snapshot is actually a good place to look at as well, because that files that you were referring to, that's a vec of record batches. So like,
exactly, but I think let's just try it. I think if we do this, and this also works, well, no, it doesn't. Shit.
So the function signatures should be improved. Like what I've learned in some of the heap track work that I've done is just taking 2 vecs out of places and putting iterators in place doesn't always fix the issue. But when I look at large tables and our performance against large tables as an example, eager snapshot as like that vec of record batches, that means if you have, I have tables that I'm responsible for that have, many gigabytes of transaction log data, like very large transaction logs. And so everywhere where we have allocated memory that's just holding on to transaction log data, and this is where like the Kernelize, the Kernelize work is starting to become more and more interesting to me, is if we can get to where I'm able to go through that transaction log, do what, like load the data. So let's say I've got 5 gigabytes of transaction log data. If I can load 5 gigabytes of data, get what I need out of it for what I'm going to do, or scan through it to get what I need to do, but not allocate 5 gigabytes of memory, that has a huge impact on the performance of things in Lambda, in other Rust-based services running in Fargate or things like that, because then the like where we are right now, the floor of how much memory I have to allocate is 5 gigabytes for that transaction log. I can never allocate less than 5 gigabytes to that process. But if we're more incremental and if we're streaming more through this data and not holding so much of it in memory if we don't need it, then the floor becomes much lower, and that means the cost and the performance comes down. But as it stands right now, like what I have to tell people, both in my day job and my night job, is the minimum size of your Lambda has to be basically the size of your transaction log. If we remove, if you do an open table on that right now, looking at the memory, that's the minimum size that you have to allocate into Lambda before you have any application logic. Like you have to have enough to allocate that open table. And eager snapshot and this loading, like keeping these allocations of files or transaction data behind these things and not being more iterable or streamable, means that you have to carry that weight around where, regardless of what you're doing. So that's more what I was referring to, not strictly just an errant 2-vec.
Absolutely. And this is exactly the reason why we expose stuff as a box stream. This is what I was referring to earlier, right? So here we have everything materialized. So this could be, this could be non-async, right? This could be an iterator, or this could just be sort of the slice of the vec or whatever.
Mm-hmm.
But by design, we expose this as a stream. Why? Because exactly to your point, and we'll have to see how that works, but we have some code lying around for more than a year also that essentially tries to say, can we, rather than materialize things, can we, one of your favorites is coming up now, can we use caching as a crutch or as a substitute?
Crutch. As long as you call it the crutch that it is, yes.
But so there may be multiple scenarios, meaning there is a scenario in which you just scan a table once and you're not going to hold on to any of it. You just discard the entire instance of the Delta table afterwards. So materializing.
The thing that we struggle with, and I struggle with it from a mental model standpoint, is if you build things in streams, like our goal, if we're building something in a stream, is to push that stream as far possible through the application lifecycle as you can get it before you have to read it. Like if you push that stream all the way to, like, let's say you're doing an optimize as an example. If loading the table gives you a stream, everything you get stream until you have to do that optimize operation. That gives us the opportunity to like collapse predicates or be as optimized as possible on reading that stream of the transaction log in order to perform the optimize. But if we, as you say, like materialize early, which we have to do in a lot of cases right now because we're not pushing streams sort of to the edge as much as we can, that means that you incur cost away from your actual operation that you're performing. And so that's why like the streaming stuff, especially with kernel, is really, really interesting to me. It's because I want to push it as far down that application pipeline as possible to where I'm not doing a wait on the stream until I'm actually doing the operation. Because if you get it all the way to merge, then the merge actually has some information that we could push down, conceptually into that stream to not read the entire stream. But I mean,
this is
we're agreeing violently about the benefit of like not materializing and streaming everywhere. Yeah. But I wanted to articulate why it's so important to me is not to be streaming inside of Delta RS, but to get it as far down the pipeline towards the operations as possible before we actually have to read the stream.
100%. And kernel supports this architecture, right? Kernel, well, I mean, yes, we have some things to look at in the making of async, but in principle, operating on chunks is kind of built in the whole into the whole idea. I think the best we can. So one thing we'll always have to do is we have to create a full plan before executing it. And especially when we talk about the log, this is kind of in the metadata planning phase. Just as a side note, I always wondered, why do we need stats on delete files? The answer is, if you have really, really big logs, you also want to push your predicate down to the delete files, so you only load the deletes that are relevant to the files, to the add actions that you might load, and you're not loading all the deletes, right? So, and this is something that we can do, right? So within the kernel scan, we can push these predicates down and then actually optimize also on that layer. But when we do the operations planning, this is where we usually have to kind of get, this is all the files I want to read, but those can also be much leaner, right? We don't need to hold on to the stats. We can discard the stats. And this is exactly kind of what we do within this replay thing, for instance, right? This replay stream, this is the stream that processes all the data that comes from the log and uses the kernel abstractions in order to extract kind of what we need to do in terms of column mapping, in terms of all of this kind of stuff. But this processes on a by batch level and then discards everything that we don't need. So we don't hold on to stats data. We don't hold on. We don't need this anymore at that point. Once we made a choice, this is something we need. Well, actually, it's not entirely true, because we want to give some stats to, well, I mean, just because we want to give DataFusion some stats. If we would say we don't want to give DataFusion file stats, then we could discard those as well. But this is kind of we don't hold on to the data. We just directly transfer it into what DataFusion wants in order to have file statistics, and then optimize away on their behalf. But this is also stuff, I mean, if this becomes limiting, yeah, but here we at least we do this on a by batch level, and we discard everything we don't need on a by batch level. So ideally, the memory footprint should be much leaner, because, well, we deal with a fraction of the data, unless you're including your string stats again.
Dude, I am not included. I am not the one that's writing to these tables. So Robert's referring to an issue where I've had to have this discussion with a number of people in the Delta RS community and the Delta Kernel RS community, where I have no control over the lunacy that goes into some of the Delta tables that we need to support. And one of the things that we discovered that was a very interesting test case was, it was a fairly narrow table. So Delta, I think by default, will only create file stats for the first 32 columns, if I recall. And string stats are so, like, the fact that we generate string stats at all is stupid to me, but we'll set that aside for another day. But if you generate string stats, you're going to have a min string, a max string, and then nulls, right? Those are your file stats that you'll have in the transaction log. And so in one particular table where the string column values were in the hundreds of megabytes large, that meant that the file stats were in the gigabytes large. Like, this was like a ridiculously large table. And I have made these assumptions that, only the best statistics are being put into file stats. But it turns out if you have a data scientist that's doing large text processing in something or another without really thinking about the underlying storage layer, which is going to be almost every data scientist. No shade against data scientists. It's not their job to think about the storage layer. But that table just like the transaction log size went like straight up. It was like a rocket in terms of how large that thing started to be. And it broke so many things in so many interesting ways because string stats are silly, I will say. I'll be polite. I'll say silly.
Yes.
So we're coming up to the end of the time, Robert. Will you please push a PR, even if it's a draft PR? Especially if it's draft PR, with the changes that you have here, because the work that you've been doing is really interesting to me. But I'm hoping that the control room can bring up our AI slop question from the very, very beginning. And I'd like to end just with a little bit of talking about AI code contributions. So whenever something asks me for a title, I'm going to put in a silly title because my official title is silly to begin with. But we've had more AI assisted, I will call them, contributions over the last six or so months. And Steve and I have talked a little bit about this, but I'm curious, Robert, for your perspective, what sort of rules do you think we should have around policy for AI generated code or AI assisted code? Like, there's some projects which outright ban it. You can't don't even bother submitting a code contribution if you're using AI tools. There's a lot of potential legal liabilities or copyright liabilities that go along with that, and why some projects do that. And then there's other projects who are checking in their Copilot or Claude or Cursor rules directly into the repo, and the maintainers are using those tools. And I'm curious where you fit, Robert, in the AI assisted for the Delta RS project. We don't have to talk about anything else. Just for Delta RS.
So yesterday I looked into a PR that was very, very ambitious in the sense of that it added column mapping, deletion vectors, liquid clustering, all in one PR. And I'm like, I guess we're done here. But there I thought about kind of some of this, because I wouldn't want to outright say, no, you can't use AI. I would go as far as taking a reasonable kind of agents MD sort of file and then putting it in there. I actually looked at the Lance one and it's great, but I would want to kind of then remind folks, you are accountable, right? We ask people to sign off the PRs, and this means you're doing it. We should never accept a PR. I mean, I'm one of the biggest culprits of having huge PRs, but doing deletion vectors, column mapping, and liquid clustering, which is kind of a completely different thing in a single PR, is certainly not the way to go in terms of structuring any project. And we need some sort of accountability there. And then I'd be happy to kind of review if what got produced, because it is possible
Perfect. Robert's on AI reviews from now on. Steve and I will.
Well, if this is kind of self-contained and constrained enough, right?
Yeah.
I would expect the one submitting also reviewing sort of their own work and not just be like, yeah, open.
Well, the thing that I struggle with, and I talked to Denny a little bit about this, is that PR as an example. I looked at the author of the PR, and I'm not going to blow anybody up on a public stream, but they're early in their career, I'll say. And so that makes me reluctant and not willing to like come down with an iron fist and say, what the hell is this? But there's a real cost, and this is where I've reached out to folks at other projects and across the industry that I know. And if we take maintainer time as a increasingly under pressure resource that we have,
which it is, yeah,
which it is, but increasingly so, AI generated code, I'm worried that you have that code has a much higher, from what I've seen, a much higher need for review. And so if we have, let's say, Robert, you have 10 hours a week to work on Delta RS. Do you want to spend 10 hours a week reviewing AI generated code? Or do you want to spend 10 hours a week building or writing code? Like, what's going to be most fulfilling for you as a maintainer? And so, like, for people that are creating that stuff, some of them are misguided. Some of them are, being lazy, all sorts of reasons, all sorts of motivations. But I'm reluctant to say, like, get lost. But I also don't want to burn up all of my available time or your available time reviewing those things. And so I'm struggling to find, like, what's our policy going to be to make it easier for us to accept or reject things without as much time going into it.
So I actually thought about how I'll answer to this PR or what I could answer there. Mm-hmm. And exactly to your point, right? So I don't want to discourage people. I want to encourage people to contribute. But in this specific case, I probably would want to give some guidance. And with guidance, I mean, first of all, if you're using AI, all right, don't tell it to just, I don't know, the prompt may have been just update Delta RS to support blah, 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 right? But you need to treat this kind of as a loop where you separate the planning and implementation. So at least that's kind of what works for me, right? If I take Claude Code, I do sort of a design thing and then to review the design and then tell it, okay, now, I don't know, write something that helps the next stage implement this. I think it's built into the workflow anyway. That yields actually pretty good results, but you need to contain it and you need this sort of review, or you need to constrain what problem you're solving. And then looking at at those PRs, if folks did this, they should be able to also answer for kind of what's happening. Mm-hmm. Right, and maybe we can make this explicit in the sense of you also need to do a first review, right? Because if they then find stuff like to do this, which is kind of, AIs like to do these kind of fallback thingies, right? So, okay, my token budget is running out. Let's just kind of null this really quick and put a to do here, right? I see this happening, and the tests still pass, but sometimes they just tweak the tests until they pass, right?
Assert true, so, yeah.
Yes. So
test done.
Somehow we need to write like a default answer, or maybe put it somewhere in the contribution guidelines, kind of what we expect for, like, what's the minimum amount of work you need to put in. Because just telling an AI add this feature and submit a PR and then just letting it run, I don't know, just burning whatever tokens, and then hoping it gets, that's going to be a waste of our time. But exactly to your point, right? So I think there is no ill intent there, and they actually believe that this AI actually implemented those features, which is in this case absolutely not the case.
No.
it just, there's, some tests are passing, but none of this is meaningful in any way. And there we just need to kind of, in a friendly tone, nudge them to, I don't know, you need to understand the problem, and then you can work with the AI, that the AI understands the problem, that you shape the context in a way that it produces meaningful stuff. And you also need to read the code yourself once, right? And delete, for instance, all the files that are meaningless, because they're kind of these summary files that AI generates and stuff like this.
Which they love to generate those too. There's a couple of really, like, the to-do thing is a really good hallmark of AI-generated code. Excessive use of emojis in documentation, I've seen, is a pretty common one. I can tell your code is not AI-assisted because it's not commented and it doesn't have tests half the time. So I appreciate your authenticity that you come to the project with. I think I'm going to have to call it for today, though. I wanted to thank you, Robert, for driving today. I'm obviously not in the Garoffice, and so this is a little different for me. But I also want to thank the control room, Carly, for setting us up with Restream today and helping manage things behind the scenes.
Yes, I felt this worked much better than when we were trying to do this somehow.
I think we should try to do this next week.
Yes. Awesome.